Welcome. In this lesson, we are going to explore traversing 2D arrays. Let's get started. We've got two learning objectives for this lesson. The first one is that we can traverse all of the elements of a two-dimensional array in what are called row major and column major order, and both of those use nested loops. The other learning goal, and this one is going to be one that's addressed by the labs more than the lesson, is that we can develop algorithms involving 2D array traversal. In order to be able to traverse all of the elements of a two-dimensional array, we're going to need a couple of loops. And those loops are going to be bound by the number of rows and columns. And so in order to get any of this to work, we have to understand how to access the number of rows and columns in a two-dimensional array. And so we'll start with the rows. So the question is, given a 2D array, how can we access the number of rows? The answer to getting the number of rows is that we say the name of our array dot length. To understand why this gives us the number of rows, it's helpful to look at this from the perspective of the fact that a two-dimensional array is really just an array of arrays. So array 2D is actually just a single dimensional array, but each element in the array is another array. So when we say array 2D.length, we're looking at the length of this array, and the length of this array is in fact the number of rows. For this particular example, the variable rows would hold the number 6 because there are 6 elements in array 2D. The next question then is, given a 2D array, how can we access the number of columns? And keep in mind that the number of rows and columns need not be the same, and in fact in this example they aren't. The way we can find the number of columns in a 2D array is we say the name of our array at index 0 dot length. And that's the difference, right? For the number of rows, we just said array 2D dot length. Here we're saying array 2D 0 dot length. The difference is subtle but important. So array 2D refers to our initial array, and array 2D 0 refers to the first element. And the first element is itself another array. So what we're actually saying is go to spot 0 and get the length of the array that's there. So array 2D 0 dot length, and that gives us the number of columns. Technically, you don't have to say 0 here. Any valid row number will work. 0 is just really commonly used because we're pretty sure we're always going to have a row 0 where I might not have a row 50. But if I did have a row 50, I could use that and it would correctly give me the number of columns. Now that we have the ability to get the number of rows and columns, we can actually start talking about traversals. And when we traverse a 2D array, just to be clear, in case you forgot what the word traversal means, it means that we want to visit every single element of the array. Maybe we want to print line them, maybe we're doing a search, who knows, but we want to visit every element. And with two-dimensional arrays, there are two potential orders we could do our visitation. The first one is called row major order. And basically what it means is we start in the top left corner and we traverse down the first row, visiting A, B, C, and D. And then after we visit the first row, we traverse down the second row, E, F, G, H, and we can see that we have the visit order below. So column major order accomplishes the same goal, but it does it in a different order. So rather than going down the rows, it starts by going down the columns, and starting in the upper left corner, visits A and E, the first column, then the second column, B, F, C, G, and D, H. And so again, all the elements are visited, it's just in a slightly different order. And so we're going to look at how to do both of those, starting with row major. In order to discuss how to implement a row major traversal in Java, I want to start really simple. So I'm not going to start talking about how to visit all the elements or even just the first row. I want to start by talking about how do I visit just the very first element of the array. And for our purposes, visiting will mean print lining, but of course it could be anything. And so the line of code you see does just that. It visits the first element of the array simply by print lining array 2D 0, 0, row 0, column 0. So that's pretty straightforward. So now we want to build on that. Let's expand on this idea by visiting the entire first row. So just like on the last slide, you can see that I've got a print line, and I do print line from array 2D. I'm still leaving the row as 0, which makes sense, right? Because I want to print the first row, which is row 0. But instead of saying 0 for the column, I've got a variable here, and that variable is controlled by a loop. Basically, what I want to do is I want to visit spot 0, 0, but then spot 0, 1, 0, 2, 0, 3, until I run out of columns. And that's what the loop does. You can see that column starts at 0. We're going to loop as long as column is less than the number of columns, which remember is the length of row 0, and then column plus plus. And so basically, by adding the loop and the variable, I'm now able to traverse the entire first row. Once we can traverse the first row of a 2D array, we want to move forward and be able to traverse all of the rows. And so for that, I add a second loop. Notice that I'm still print lining from array 2D. I'm still controlling the column with a loop so that it goes 0, 1, 2, 3. But now I'm also going to control the row with a loop and a variable. So basically what will happen is when row is 0, the first row, we will loop through all the columns, and that covers us for our first row. But then once we've finished with that row, we go all the way back to the top and row becomes a 1. So now we're down here on the second row, and we'll do a 1 here and again loop through all the columns. 1, 0, 1, 1, 1, 2, 1, 3. And with this loop inside of a loop, this nested loop structure, we can visit all the elements. Now, if this isn't making sense to you, I would just encourage you to pause the video and think it through, because understanding this is going to be critical to understanding all the exercises you're going to do with this lesson. When you're doing a row major traversal, you can also use for each loops. Now, we know that for each loops have some drawbacks. For instance, they don't deal with index values, which if you need to deal with index values is a problem. And also, for each loops aren't necessarily good at changing the array. But if you can live with those drawbacks, then a for each loop, clearly you can see, is less code and easier to read. So let's break down how it works. So our outer loop says for string array row in 2D, in array 2D. Now, it looks a little weird that we're breaking out a string array suddenly, but remember that a 2D array is an array of arrays. So each row, like ABCD, is an array of strings. And EFGH is another array of strings. So this outer loop is going to take each row, each array in turn. Then the inner loop is going to go through every string element in that row. So in other words, we're going to start at the first row, and then we're going to rip through all the values in that row. And then we're going to go to the second row and rip through all the values in that row. And so it accomplishes the same thing as the traditional for loop. It just does it looking at the elements rather than dealing with the indexes. Now that we've unpacked row major order, let's turn our attention to column major order. And this will be pretty quick because we've already figured out how most of this works. So remember first that in row major order, we're trying to visit the elements by going down the first row, then down the second row, etc. Column major order flips the script, and we start at the first column and we go down, go to the second column down, etc., etc. And it's really easy to modify our row major code into column major. All we actually have to do is we flip-flop the two loops. So where before with the row major, we had our row loop first, here we have our column loop first. And the idea is this: column will start out at 0, and then our inner loop will go through the rows. So we start at column 0 and go through the rows. Then column becomes a 1 and we go through the rows, and column becomes a 2 and we go through the rows, etc. And if you think about it a little bit, it makes perfect sense. Just keep in mind that when we control our loops and their stopping point, that with the column loop, we are still using the number of columns, and with the row loop, we're still controlling that with the number of rows. So literally, this is the same as a row major traversal, but we flip-flop the loops so that we get that different order of visitation. One last important thing to know about column major traversals is that you cannot do them with for each loops, and that's simply because of how Java works. With a row major traversal, I can just say for each row in the 2D array. In other words, I can access the row directly and in its entirety because Java stores each row as a separate array. However, because Java doesn't store the columns like that, there's no way to just say, hey, I want to go through each column of the array. It's impossible to say that. And so for column major, we're going to be restricted to traditional for loops. All right, time for an understanding check. So what I've got here is a partially completed method called row sum. And row sum has two parameters. One is a 2D array, and then the other is a row number. And the purpose of the method is to compute and return the sum of the row. So for example, here in the lower left, if I said row sum array 2D1, the method would add up row 1 and return the result of those numbers added together, which in this case is 26. So what I'd like you to do is pause the video and really think about like how you would write that code, and then when you're ready, resume and we'll talk through the answer. The solution to this problem relies on this variable sum, which starts at 0, and then using a loop, you can see that I add on to the sum variable. And if you look, when I add on to the sum variable, I access my array. And the row I already know. I already know what row I need to add up because that was passed as a parameter. But the row consists of multiple columns. And so that's why I have another variable here, column, that I control with the loop starting at 0 and ending at the number of columns. So basically, I use the row I already know, and then the loop allows me to travel down the row, and I return the sum at the end. All right, now that you've watched this lesson, you should be able to traverse all the elements of a 2D array in both row major and column major order using nested loops. And in the exercises, you're going to be able to practice developing algorithms involving 2D array traversals.